Okay, I'm going to do a couple of examples with you today, and this is especially if you missed today's lesson. So the top 6 are a review of what we've been doing the past couple of days with the graphing. So I'll just graph a couple of these and come back and use them in just a minute. So I'm going to graph K because I think that's one y'all might have a little bit more trouble with. And the first thing I want to look at is the vertex. So remember, you change the sign, so it's going to be -1, 2. And because it opens down, it's going to be a maximum at -1, 2. So I'm going to put that point in place, so -1, 2. And again, it's going to open down with a slope of 1/2, meaning I'm going to go down 1, 2 to the right, and down 1, 2 to the left, just to get my two different pieces of the graph started. So then go down 1, 2 to the right, down 1, 2 to the right, etc. So from here, down 1, 2 to the left, down 1, 2 to the left. And then I'm going to put the line segments in place and make them as straight as possible. Okay, so today we're learning how to solve equations regarding absolute values and also inequalities with absolute values. So I'm going to first start by looking at K equals -1. And the way you're going to do that is you're going to actually go in and put a line at -1. And you're looking for where it intersects with your graph. So when I'm going to draw this in red so you can see it a little bit better. So when I put that in place, I can see that it intersects right here at this x of 1, 2, 3, 4, 5. And then also down here, and this x would be -1, 2, 3, 4, 5, 6, 7. So the answer to this is right here, is going to be x is a 5 and a -7. And that's the solution. And you're basically just looking at where it intersects with this line. Okay, let me make sure you understand what this even means. So if I have K of x is equal to -1, this is really saying, where does the function K equal -1? And even further than that, it means, where does y equal to -1? And we want the x values where y is equal to -1. So that's what we're doing here. Okay, so I'm also going to solve number 4 with you. And here we're looking at where K is greater than or equal to a +1. So it's a different intersection that we're looking for. So I'm going to come back to this graph and I'm going to put in a line at 1 right here. And hopefully you'll see it better this time. Okay, so I'm looking for where it intersects with this line at 1. And for some reason this is just not showing up very well. Okay, so it intersects right here and it intersects right here. And I'm looking for where the line is greater than or equal to that 1. So all of these x's from -3 to a +1, my y's are greater than or equal to. So this solution is going to be all x's between -3 and a +1. And because there's an underline there showing that it's equal to as well, I can include the -3 and the 1. And that would be the answer to that one. So that's solving these graphically. We also need to learn how to solve these algebraically. So if you flip over to the back for the notes, and I'm also attaching all these different answers down here, so I'm just going to jump straight to a couple of examples with you. So when we solve these, we need to remember that we can have two different values inside the absolute value symbol that would give us a 5. It could be a +5 or a -5. And the reason I say that is if I have a +5 in the absolute value, I get 5. If I have a -5 in the absolute value, I also get 5. So I'm going to have to set up two different equations for this. So I'm going to say x plus 2 equals 5, and then also x plus 2 equals a -5. And then I'm going to solve. So subtract 2 from both sides. Here I get x is 3. Subtract 2 from both sides. Here I get x is going to be a -7. Well, you may be wondering, how could that possibly be? Well, it's because if you go back to the original equation, x plus 2 equals 5, and plug in a 3, I get 5, and the absolute value of that obviously is 5. When I plug in a negative 7 plus 2, I get a negative 5. So that's this version right here. So both of these are solutions to this absolute value equation. Now, the first thing you want to do every time you do one of these is you want to make sure that you isolate the absolute value. So for example, in number 2, I'd have to subtract 4 first, and I get the absolute value of x minus 5 is equal to 2. Now is the time when I'm going to set up two different equations. So I'm going to do x minus 5 equals 2, and x minus 5 equals a negative 2. And I'm going to solve. So add 5. Here I get x is 7. Add 5. And here I get x is a 3. So when I plug it back in just to test it, if I get 7 minus 5, that's a 2, so the absolute value is a 2. If I do 3 minus 5, I get a negative 2, which the absolute value of that is also 2. And either time I add it to 4, I get a 6 there. So I know these definitely both work, and these are my solutions. They do get a little bit more complicated. I'm going to jump to number 4 over here. And what I want to remind you is when you are solving, you use reverse PEMDAS, which means the first thing you're going to do is add or subtract. And remember, our goal here is to isolate, and I'll use the highlighter here, to isolate this absolute value function, or the absolute value there. So the first thing I'm going to do is add or subtract. So I see a 6 is being added here, so I'm going to subtract it from both sides. So I end up with 3, absolute value of x plus 1, and then that'll go away, of course, and that gives me a negative 3. Then I'm going to go to multiplication or division. This is multiplied by 3, so I'm going to divide by 3 to get started, or to isolate that. So I'm going to divide by 3. And then I have x plus 1 is equal to a negative 1. As soon as I see this, I know this is impossible, because the absolute value is a distance, and there's no way to have a negative distance. So I'm not even going to waste my time solving that. There is no solution. Okay, now let's try a couple of inequalities. Those were all equations that we were solving. So let's try a couple of inequalities. So I'm going to start by looking at this and remembering that if I divide or multiply by negative, I have to reverse that symbol. Okay, so this is isolated, and I know I'm going to have two different equations just like up above. The trick here is, though, when I do x minus 2 greater than 4, that's one of them. X minus 2 is, I'm going to actually have to reverse the symbol because I'm changing the sign. I'm essentially dividing by a negative 1 there. So don't forget, you must reverse the symbol. And please be sure to look at the notes that I sent out as well, because those give you the fill in the blanks up above. And that talks about that. So when I solve this, I do x plus 2. I'm going to add 2 to both sides, and I get x is greater than 6. When I add 2 here, add 2 here, I get x is less than a negative 2. Now, this is really important that you put in a number line so you can understand how to write your solution. So this is just your x-axis essentially, but I'm drawing it as a number line. I'm going to put in a negative 2, and I'm going to put in a 6. And I'm going to put them in order. The distance doesn't really matter. But when I look at x greater than 6, it's this region over here. When I look at x less than negative 2, it's this region over here. So I'm going to have two different intervals, and I'm going to use my number line to help assist in writing those answers. So it's going to be negative infinity to negative 2, and because that's not bubbled in, because that is not this one's not underlined, I'm going to use parentheses. Same thing, because 6 is not bubbled in, because 6 is not part of our solution here. So I don't want to use brackets, I want to use parentheses. Okay, now let's do one that gets a little bit harder. So again, I must isolate my absolute value. So there's no multiplication out front, so the first thing I'm going to do is just subtract that 1. Don't even have to really think about it too much. So subtract 1. Here I get x plus 3 is greater than or equal to 5. And this is when I set up my two different equations. So I have x plus 3 greater than or equal to 5, x plus 3 less than or equal to a negative 5, like that. And then I subtract 3 from both sides, and I get x greater than or equal to 2, subtract 3 here, and I get x is less than or equal to a negative 8. Again, use a number line to kind of help you write your answers. Negative infinity to positive infinity. And then I have 2, and it's greater than 2. Greater than or equal to, so I'm going to bubble this one in. And this is my solution region there. And then I have negative 8 over here, and it's going to be to the left of that. So negative 8. So my solution is going to be negative infinity to negative 8 in union with 2 to infinity. And I need to make sure to use the brackets here. See, I made that mistake too. You have to just kind of double check everything before you write your final answer. But that would be my solution. It would be all x's from negative infinity to negative 8, and then from positive 2 to infinity, and that's your solution. Okay, I think we have time for one more, so I'm going to do this one right here. Again, with PEMDAS, working backwards, but there's nothing to add or subtract, so the first thing I'm going to do is divide by the negative 3. And as soon as I divide by that negative, I have to remind myself I must reverse the symbol. So it's going to be x plus 4 in the absolute value, but now it's going to be less than or equal to a positive 2 when I do this, because I divided by a negative. Here I set up my equation, x plus 4 less than or equal to 2, x plus 4 greater than or equal to negative 2. So I had to reverse my sign, my symbol a couple of times, so be very careful with that. So subtract 4, and then that goes away, of course. I have x less than or equal to negative 2, subtract 4, x is greater than or equal to a negative 6. When I put my number line in place, I have a negative 6, and I'm going to bubble it in because it is included in the solution, and then I have a negative 2. Remember, negative 6 is to the left of negative 2 on the number line. It's more negative, so it goes to the left. Now, x less than or equal to negative 2 is this way. X greater than or equal to negative 6 is this way. So now I only have one interval here. It's going to be negative 6 to negative 2 inclusive of those two values. And that would be my solution there. All right, so fill in the notes that I sent out, and that should help you so that you're not behind tomorrow.